Okay, the next problem wants us to solve this log equation. So we're going to do 4 to the negative 1 equals x minus 5 because we know a log is an exponent. So we can do base to the exponent equals the argument to change it into exponential form. This is really 1/4 equals x minus 5. We can add 5 to both sides. So we get this. Let's do a common denominator. Let's make this 20 over 4 by multiplying top and bottom by 4. So our final answer ends up being 21 over 4 for x. Now you can plug this back in and use your calculator and you will get -1 here, which is actually important to check because a lot of these are going to be extraneous. If it's negative or 0 especially, because you can't take the log of a negative number or 0. So keep that in mind. If you get a negative or 0, it's always extraneous. Okay, I would solve this by, you could graph it obviously, graph the left and the right, find the solution, but I like to change it into exponential form, so it would be base to the exponent equals x squared, and then you just take the square root of both sides and you get x equals plus or minus the square root of 10 to the 6th, which you can do in your calculator as a decimal if you want. We know the negative number is no good because that's extraneous, so let's just use the positive answer, and it will work if you plug that in. I'm sorry, actually both work. The negative works as well because the negative squared gives you back the positive. So both the plus and the minus work in this case because of x squared. Okay, this next problem is really tough. It's probably too long to put on an exam, and it's really tricky. Basically, we're going to multiply both sides by 2, and we're going to get this. Now, we need to somehow figure out how we can rewrite this, because at this point, we don't know how to solve this. So I'm going to rewrite this as 1 over e to the x. Then I can multiply through by e to the x, and if I multiply through by e to the x, I end up getting e to the x times everything. So these would cancel, and you just get 1. E to the x times e to the x is really e to the 2x, because when you multiply like bases, you add the exponents. Plus 1 equals 8 e to the x. Now, basically, I can recognize that I actually have a quadratic relationship here. You might not be used to seeing this, but when you have 2 times x and then 1 times x, that's a quadratic relationship because I'll rewrite it and show you. If I call another variable like w, if I call it e to the x, then what w squared would be e to the x times e to the x, obviously, which is e to the 2x. So basically, if I I'll let this equal w squared, e to the 2x, and e to the x is w. Now I've got a quadratic. Now what makes this problem even harder is that they're not whole numbers now, so I have to solve for w using the quadratic formula, which is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So this gives you square root of 60. So here's my answers, but unfortunately these are my answers for w, not e to the x. So I have to write e to the x equals this, and then I have to take the natural log of both sides. So x actually equals the natural log of 8 plus or minus the square root of 60 over 2. You have to do both of those, and if you do both of those, you end up getting some decimals. Looks like you get plus or minus 2.0634 about. So that's a very, very tough problem. Okay, let's solve another log equation. This is natural log of x plus 3 raised to the 1/2 minus natural log of x equals 0. If I bring the exponent up, now use the quotient property that says that the log of a quotient is the difference of two logs, so we'll go backwards and make this quotient, x plus 3 to the 1/2 all over x, and that equals 0. Now I'll write this in exponential form, so I'll do e to the 0th equals this. I'm going to write this as the square root of x plus 3 instead of the 1/2. So now I'm left with this right here. I'm going to, I guess, multiply both sides by x. E to the 0th is just 1. So if I multiply both sides by x, I get this. Then if I square both sides, I end up with x squared equals x plus 3. And I can then subtract x and 3 from both sides, and hopefully factor this as well. X minus 3, x plus 1, no. So unfortunately I'm going to have to use the quadratic formula again, opposite of b plus or minus square root of b squared minus 4ac all over 2a. Double negatives go positive, 4 times 3 is 12, plus 1 is 13. So there's my two answers. Now, one of these might be extraneous. Yeah, it is. This 1 minus square root of 13 is a negative number, so that minus isn't going to work. We can't have a negative once again because we can't take the log of a negative. And if you're not sure why, try taking the log of something negative and see what you get. What you get is you get e to the x equals negative 1. Well, there's no way, when you change this into exponential form, there's no way to raise e to a number to get a negative number. So you can't have negatives, so therefore we just do the positive one. There's our solution, which we could give as a decimal as well. As a decimal, I think it's about 2.3028. Okay, the next problem is really important, logistic functions. And I'm going to have to go over this in class some more because there's one problem on the exam that has to do with this, and we didn't get a chance to practice these because these were not in web work. So we're going to have to go over this. It's on the formula sheet, so it's pretty straightforward. Here's the formula for logistic growth. We can use E as well, but let's use this form because it just wants us to find a logistic function that satisfies these conditions. So this C right here is the limit to growth, so that's 30. So far my function becomes 30 over 1 plus AB to the x. Now, they also tell me the initial value is 12. What that means is when you plug in 0, you get 12. So I'm going to go ahead and do that. Plug in 12 for y, and plug in 0 for x. If I do that, I get 1 plus a, because b to the 0th is 1. Now I can solve for a. So multiply both sides by 1 plus a. And you get this. Divide both sides by 12, and then subtract 1 from both sides. Subtracting 1 is really the same as subtracting 12 over 12. So you get 18 over 12, which simplifies. 6 goes into both, 3 over 2. So a is 3/2. So now I get this function if I plug in 3/2 for a. So I'm getting closer. Now I can do one more thing to find b, and that's to use the point that they gave me. The point was 220. So I'm going to plug in 20 for y, and I'm going to plug in 2 for x. And now I need to solve for b. Okay, so I'm going to multiply both sides by this quantity, 1 plus 3/2 b squared equals 30. Now I'm going to divide both sides by 20. The zeros cancel, so I get 3/2. I can drop these parentheses now. I'm going to subtract 1 from both sides, which is the same as subtracting 2 over 2. So now I have 3/2 b squared equals 1/2. Now I can multiply through by 2/3. Multiply the other side by 2/3, the 2's cancel. And I get b squared equals 1/3. So if I take the square root of both sides, I get b equals plus or minus the square root of 1/3. I'm just going to use the positive there. We don't want the negative. So my final answer is what I get if I plug in the square root of 1 over 3 and for b. So there's my logistic function. Now I know our answers use the E formula, which you're more than welcome to do it. Here's the work for that. You might want to double check that. You can use E here as well. I'm going to stick to this function here. So I'm going to do this problem again, but for number 24. All right, so they give us the limit to growth again is 20. So I'm going to put that in the top. 1 plus a b to the x. They say the initial height is 6. So what that means when I plug in 0 for x, I get 6 for y. I can then solve this. This is 1, so I get 6 equals 20 over 1 plus a. Multiply both sides by 1 plus a. And then divide both sides by 6. And I can subtract 1 from both sides, which is really 6 over 6. And a is equal to 14 over 6, which simplifies to 7/3. I divide top and bottom by 2. So a is 7/3 here. Now I just want to find what b is. So in order to find b, I'm going to use the point that they gave me. They gave me the point 315. So 15 goes in for y, 3 goes in for x. I need to find this value right here. So I'm going to multiply both sides. by this 1 plus 7/3 b cubed. And I'm going to divide both sides by 15. I have 1 plus 7/3 b cubed equals 20 over 15, which is 4/3. Subtract 1 from both sides, and that's really 3 over 3. So that'd be 7/3 b cubed equals 1/3. Multiply through by 3/7. And you get b cubed equals 1/7. And then cube root both sides. And you get b equals the cube root of 1 over 7 as your this value right here. The cube root of 1 over 7 to the x power. So there's my logistic function when I'm done right there. Now you can compare it to what the book has and you'll find out that this value right here is the same as what they have right here with that e to the negative 0.65. If you do e to the negative 0.65, it should be about the same decimal as that right there. Okay, let's solve a couple more equations. To solve these, you can put them right into log form. Log base 1.05 of 3 equals x, because a log is an exponent. So this is something you can do right in your calculator. If you use the alpha window, log base is 5, and that's 1.05 of 3, and it gives you your answer of 22.517 for x. Same thing here, you can just change it in exponential form, e to the 5.4 equals x, and that's something you can do in your calculator, hopefully very easily. E is down here to the 5.4. Gives you your answer of about 221.4. And I'll try to be specific about how I want you to round on the exam as well. But since it doesn't say here, we'll just do 10th here, and I guess we can do 10th here as well. Okay, solving more log equations. 53 here, this first one. You can use log properties to simplify because this sum of two logs is really the log of a product, x plus 2 times x minus 1 equals 4. Now you can put it in exponential form, 10 to the 4th equals this right here, which I'm going to FOIL out in one step. X squared minus x plus 2x minus 2. And these add together to be 1x. Now I've got a quadratic. It's 10 to the 4th. I'm going to subtract from both sides. I know that's a big number, so I'm going to get 0 equals x squared plus x. And this number right here is 10,002. Negative 10,002. So I'm going to have to use the quadratic formula on this now, which is opposite of b, plus or minus the square root of b squared minus 4ac. These double negatives go positive, all over 2a, and I'm going to get a couple decimals here for my answers. Now keep in mind that I don't want the negative, so I only want the positive, because I can't take the log of a negative number. And you can always double check that, but we'll probably only want this positive one, and that is going to give me a decimal. And you end up getting 99.5, and that's the same thing that they get right here. I didn't quite follow their work though. They didn't show their work for the quadratic formula in a way that I understood. I don't know where that 9's coming from, but either way we got the same decimal in the end, which is right here. Next problem, same thing. Use log properties to write the log of a quotient plus 5. Now put it into exponential form. Then multiply both sides by 2x plus 1. Now distribute and then get the x's together. Now I'm going to subtract 3x from both sides. And also move this over to the right as well. So I end up with this, and I can factor out an x. And then divide by this number right here. So this should give me my answer right there as a decimal that is about negative 0.49.